In this video, we're going to be deriving the height of a regular triangular pyramid with side S. So what we're going to be looking for is this height right here. So it's going to be perpendicular to our base and go all the way up to the tip of the pyramid. And it's not so difficult to find, but it does take a little bit of thinking. So really what we want to do is, I see that I have a flat base here and the height going perpendicular to it. So I'm going to try and make a right triangle that can help me find that height using parts that I know. So what I'm going to do is, I'm going to do my best to draw it here, but I'll redraw it in a second. I'm going to draw, do you see this right triangle here? That's the right triangle I'm going to use. So I'll leave the height dotted, but we'll draw this in. This line from the center of the base to a corner, and then I'm going to use one of the sides as my hypotenuse, and then I'm going to find this height h. So next what I'm going to do is just look at, let's just look at the base for a moment. So if this is the base, so that's, let's see, we'll just kind of draw an arrow here or there. So we'll take the base. Now, I'll draw in red. Actually, let's draw, we want to find the middle of this base. And it's an equilateral triangle with sides S. So in order to find the middle here, I'm going to draw this line. Now, in an equilateral triangle, it's interesting because if I were to do that in any other triangle, normally we'd call it an altitude, and it would, in most cases, just be an altitude. But in an equilateral triangle, it's an altitude, it's a median, it's a perpendicular bisector, and it is an angle bisector. And if we draw three of these, they'll all intersect in one point, and that's going to be our center. And if I were to continue with this red that we're looking for, that's where my height is going to start. So what we're looking for, remember, if we look back in our original drawing with that red triangle, we're really looking for this right here. We're looking for this side because that's going to be this part of our triangle. And then, since we know this part is already S, we've got 2 out of our 3 sides, and we can use that in Pythagorean theorem. So let's go look at this triangle and see what we can figure out. Well, we know that we started with an equilateral triangle, and we bisected this angle. So it started off as 60, and now it's going to be 30. Since I have that 90-degree angle there, I know that this is going to be 60. So I'm going to work with that triangle for a moment. So let's draw that a little bigger over here. Let's zoom in on that. So there's that triangle, 60, 30. And what do I know? Well, since I perpendicularly bisected this side, and it started as S, this chunk here, which is now the base of this triangle, should be half of that, or S over 2. So I'm going to label that as S over 2. And one thing that's going to help us here, I'm going to draw another 30, 60, 90 just to compare to. We remember that the ratio of the sides of a 30, 60, 90 triangle are x, 2x, and x root 3. So what we know is that this S over 2 is opposite the 60-degree side. So we can write an equation here that says S over 2 equals x over root 3. And the reason I want to do this is because I can use this to find the other 3 sides of my triangle, which is nice because this hypotenuse is what I'm looking for, right? So if I can use my special right triangle, I should be able to figure out what that other side is. So I get that x is s over 2 over root 3. So I'll just put that root 3 down there. And if we wanted to neaten things up, we could multiply by root 3 over root 3, rationalize the denominator, and we're going to get s root 3 over 6. Now, what does that mean? That means that the side opposite the 30, right? Because my x here is opposite the 30. So in this triangle, this side is going to be my s root 3 over 6. So I'm going to go ahead and label that s root 3 over 6. And now this third side is twice that. So this side should be 2 times s root 3 over 6, which is going to be s root 3 over 3. And I multiply by 2. And now that I've found this side right here. It is s root 3 over 3. So I think we're ready to form our Pythagorean theorem. Remember, it's side 1 squared plus side 2 squared equals hypotenuse squared, a squared plus b squared equals c squared. We've seen it a lot of different ways, but basically in this case it's going to look like this. H squared plus s root 3 over 3 quantity squared equals, now this third side was the easy one. That's just the s. So that's just going to be s squared. So let's do some algebra here and simplify this. So I'm just going to subtract everything over. So h squared is s squared minus s root 3 over 3 squared. Now let's square everything in the parentheses. So h squared equals s squared minus s squared times 3 over 9. And then what we can do is we can write that s squared as 9s squared over 9 and subtract, and what we end up getting down to is h squared equals 6s squared over 9. And now I'm going to kind of shoot over here, get some more room. That's going to mean that h is square root of 6s over 3. And there's our equation for the height of a regular triangular pyramid that has a side s.